Alaikum. Welcome back class. Today we'll discuss another lecture of separation process 1. Today is 25th of March 2025. So let us have some insight of the today's topic. So we will discuss about the adsorption today. It's the lecture number 2 on adsorption. The first lecture about introduction to adsorption, its explanation, its general phenomenon, and its basic concepts were discussed in the last lecture. Today we'll discuss about adsorption equilibrium and Bronier, Emmett, and Teller isotherms. Adsorption combined known as adsorption isotherms or BET isotherms. So let us have a recap from the last lecture. Little bit about the adsorption. It's basically a separation technique where we have the phases involved are mostly solid and gas or liquid. So solid is basically a solid bed in which adsorbents are usually the adsorbents, they are solids and they are packed in a container, and the gas stream or liquid stream is passed through them, and the unwanted or another precious thing from the gas stream is separated out in the adsorbent bed, and the other remaining gas is taken out from the exit. So basically here adsorption is the phenomenon of attracting and retaining the molecules of a substance on the surface of the liquid or solid, resulting into a higher concentration of that molecules on the surface. So little bit about again, A is here the adsorbent and B is the adsorbate, which is basically gas or liquid form, and A is solid and B is gas, or it can be liquid, but mostly our case or industry we use gas adsorption. So adsorbate is the B, the substance adsorbed onto the surface, and adsorbent is that substance onto which the new molecules are attached. And we have interface, the surface where the process takes place is known as the interface. So little bit about the last concept, that we have physical adsorption and chemical adsorption. So this is basically a physical adsorption in which the molecules of B are retained on the surface of A and are captured there through weak van der Waals forces, and then that can be removed again by the regenerating the column through steam. So another concept we discussed about the simple surface, or we have sample surface, sorry, and multi-layer and unimolecular layer uh, adsorption. So mostly uni-layer is in the chemical adsorption and multi-layer is for the physical adsorption. So what now let us discuss about the adsorbents. We have discussed in detail in the last lecture, but here we'll discuss about how the adsorbents are being activated uh, through their original form, because if we use them as original form, they will not attract many like molecules of B. When they are activated, they attract like more molecules and their efficiency is increased. So first of all, if you have raw coal, you can store it and then pulverize it, like that means converting to smaller particles or smaller like samples, and then you go through a agglomeration process and then again crush them and then bake them in an oven or like certain furnace. Here the temperature is around 160 to 200 degrees Celsius. 160 to 200 degrees Celsius is the temperature in the baking. Uh, then we move to the activation zone. Here the temperature is around 800 to 1000 degrees Celsius, and then we screen it, and now finally we get the two types of activated carbon, PAC and GAC. PAC stands for powdered activated carbon and GAC stands for granular activated carbon. So both can be used depending upon the requirements of the adsorbents in the adsorption column. So here are different forms of like activated carbon, powder form, granular form, or extruded form. These three types can be used depending upon the requirements. So the basic thing is that as you reduce the size, the surface area increases and you can have more like option for the adsorbate to get adsorbed on the surface of the adsorbents. So, by reducing the size, you can increase the surface area. But on the other hand, if you have more smaller size particles, the pressure drop will increase. That's not favorable or not required. So we choose an optimum size that you have maximum, you can have maximum surface area, and also pressure drop is retained at the required level. So let us move towards the adsorption equilibrium. This graph we already discussed in the last lecture. So on the x-axis we have C, which represents the adsorbate in the solution per unit volume. So for example, we are at certain place here in the x-axis, and on the y we have W, which represents the mass of adsorbate uh, to the mass of adsorbent. So mass of adsorbent is usually fixed, of course, like the adsorbent, the solid packing or bed. So mass of adsorbate will of course increase or decrease with respect to time. Like, so we have three conditions. We have unfavorable adsorption, we have favorable adsorption, and we have this linear trend. This is the linear trend, like as the adsorbate is increased in the main feed stream, the adsorbent is also increased in the adsorbent is also increased in the in the adsorption column. So if we set this, like we have this x-axis, this point, and we move towards the y-axis and see here the compare these three lines. So at the unfavorable condition, you can see that we have lower value of in the y-axis, and linear trend we have higher value, and then for the favorable we have even higher value. So this is the most favorable or most like efficient adsorption is taking place in this favorable curve. So these curves basically actually, like when you practically use different gases, for example, separate air, we have nitrogen, mixture of oxygen and carbon dioxide, or any different gases, you can we will discuss further. So they have different trends at different temperatures, different conditions. They have different trends. So some show favorable conditions, some show unfavorable conditions. So adsorption of gases and vapors on solids. Any solid is capable of absorbing a certain amount of gas. The extent of adsorption at equilibrium depending upon the, so there are three factors onto which the adsorption depends upon: the temperature, the pressure of the gas, and the active surface area of the solid. So as I told you before that adsorption adsorption is a natural phenomena. Also you can I give you two examples. Like for example, in the medicine box you have a certain packet inside, and there are solid uh, uh, granules inside that. That's basically of silica gel, and its function is to absorb the moisture from the surrounding. And also if you see certain like spices or salt in your kitchen, after certain time they get little bit wet, so that's also an absorption phenomena. Or you just put certain food in the room for certain time, you can see the like its contexture is uh, uh, changing and more moisture is coming inside that. So that's basically absorption phenomena. So in practical, absorption depends upon temperature, pressure of the gas, effective surface area of the solid. So the most notable absorbents are must be highly porous solids such as charcoal, silica gel, which have large internal surface areas up to around 1000 meters square per gram, and finely divided powders. So this relationship at a given temperature, uh, like you can fix the temperature 30 degree, 40 degree, 50 degree, any temperature, between the equilibrium amount of gas adsorbed and the pressure of the gas, is known as the adsorption isotherms. So here we see the example of absorption isotherm. For example, we have x-axis, we have different pressures, and 0.2, 0.4, and on the y-axis we have volume of gas adsorbed per centimeter cube at STP, standard temperature and pressure. So let us fix the pressure, like we have 0.8 is the pressure, Newton per meter square, and now you can see, if you move towards the y-axis, we have different points. I just compare two temperatures. For example, we have temperature 353 Kelvin. At 353 Kelvin, we have this much as adsorption takes place, and at 250 Kelvin, we have this much adsorption takes place. Now you see that these temperature trends is basically increasing in the downward direction. So temperature, for example, here is 250, then we have 253, 273, sorry, 303, 353, 425. So temperature is increasing downward. So that means at low temperature, we have high adsorption. And as we increase the temperature, the adsorption rate becomes minimized. That means because we know that as we increase the temperature, the kinetic energy of the molecules increase. So the molecules tends to move faster, and rather than retaining on the adsorption column or onto the adsorbents, they tend to move away and exit from the column. So if you want to form adsorption, you must see the temperature and have certain optimum temperature at which lie at the lower temperature. So it's very low temperatures, like 273 will be 0 degrees Celsius, or 30 degrees Celsius, even minus in the minus temperature in degrees Celsius. So you can see that the gases, they absorbed at the very low temperature if you fix the pressure. On the other hand, if you increase the pressure, while if you see just the trend of the pressure, as the pressure is increased, the adsorption is increased. That's the trend between the pressure and the volume of adsorption. So to summarize it, general trend is that as you increase the temperature, the adsorption decreases, and as you increase the pressure, the adsorption also increases. So let us now classify the different types of adsorption isotherms that are basically attained while different gases, actual gases, and actual adsorbents. So the phenomena may be involved in physical adsorption. So there are two types of main adsorption. We discussed monomolecular adsorption and multimolecular adsorption. It's not compulsory that the monomolecular will always be a chemical reaction. It could be a physical reaction, but maybe there's no space left for, or not any other attraction left for the molecules to stay on that adsorbent surface. So Bronnier's classification of adsorption isotherms, now discuss that P naught is the saturated vapor pressure here. So we have usually 5 types of isotherms. We discuss them one by one. Type 1 isotherms, basically it's shown practically between the ammonia case. Ammonia on charcoal at 273 Kelvin shows a fairly rapid rise in the amount of adsorption with increasing pressure up to a limiting value. So this is type 1. As you increase the pressure, the adsorption increases fairly rapidly, and then after a certain time it becomes constant. They are referred to as Langmuir. Type 1 isotherms are also referred as or known as Langmuir type isotherms, and are obtained when adsorption is restricted to a monolayer, only a monolayer adsorption. This is for the monolayer adsorption. And type 1 isotherms have also been found on physical adsorption on solids containing very fine pore structure, and nitrogen on microporous carbon is also an example of type 1 at 77 Kelvin, very low temperature. So type 1 isotherms में क्या क्या बातें आई हमारे पास कि जी आपके पास एक बहुत शुरू में इंक्रीज आता है, जैसे प्रेशर बढ़ता है तो एब्जॉर्प्शन इंक्रीज आता है, फिर उसके बाद थोड़ी देर बाद जाके वो कांस्टेंट हो जाता है। और उसके बाद क्या होता है जी, इसको हम लैंगमुइर आइसोथर्म्स भी कहते हैं, लैंगमुइर टाइप। और इसमें ये मोनोलेयर के लिए होता है ज़्यादातर, और ये वेरी पोरस स्ट्रक्चर के लिए जो आपके पास टाइप 1 आइसोथर्म्स बनता है। जी, this you can see the type 1 isotherms. These are the 5 types, be it isotherms type 1, type 2, type 3, type 4, type 5. So there are 5 types. On the x-axis we have usually pressure, relative pressure, on the x-axis. On the y-axis we have amount adsorbed, like amount of adsorbed. So here you can see type 1, as I told you before, that there's fairly rapid increase as the pressure increase, but after certain pressure it becomes constant. So this is the like maximum adsorption at takes place at this place and at this pressure. After that it's constant. So this is type 1. So type 2, we can discuss. Type 2, just seeing the trend of this graph, this is for the type 2 type isotherms. So here we also have a rapid increase, but after certain pressure it becomes like constant, and then again it increases after certain pressure. This is type 2. On the type 3 we have like first we don't have like rapid increase, we have like lower increase as compared to the type 1, and then after certain time, like certain pressure, as the pressure increases, the value again increases. This is mostly for the multi-layer adsorption. uh, so type 4 is like first we have increase, and then there becomes a little bit like constant, and then again we have increase, like again we have increase in the adsorption. So type 4 and type 5 almost are similar behavior, and we'll discuss more of them in the further slides. So this is basically shown the type 1 again. Type 1 type trend of the isotherm like fairly increases. First is increases as the pressure increases, the adsorption, and then reaches at the maximum amount of adsorbed at this pressure. And again, if we have type like 4, then it will be like this, but in type 1 it goes straight and just remain constant. So let us discuss one by one what are basically happening in these graphs, or what's actually like the molecules, how they are behaving, and how these graphs are different. For example, type 2 isotherms, it's basically shown in the case of nitrogen on silica gel. Like if you want to separate nitrogen from oxygen in the air, and nitrogen is adsorbed onto the silica gel, that's the case of the type 2 isotherms. So these are frequently encountered and present multi-layer. So in type 2 we have multi-layer physical adsorption, and basically non-porous solids, like they are non-porous, so they are basically different from the type 1. टाइप 1 में हमारे पास मोनोलेयर था और पोरस था, टाइप 2 में हमारे पास मल्टीलेयर फिजिकल एब्जॉर्प्शन है और नॉन पोरस सॉलिड्स हो गए। ठीक है जी, और इनको हम सिग्मोइड आइसोथर्म्स भी कहते हैं, जबकि टाइप 1 को हम लैंगमेयर आइसोथर्म्स कहते थे, लैंगमेयर टाइप आइसोथर्म्स। सो पॉइंट बी रिप्रेजेंट द फॉर्मेशन ऑफ एन एड्सॉर्ब्ड मोनोलेयर। अच्छा जी, यहाँ पे देखिए आपके पास पहले, क्योंकि सबसे पहले मोनोलेयर बननी है, जितने एक्टिव साइट्स हैं उन पे जाके एड्सॉर्बेट ने एड्सॉर्ब होना है, तो एक वो तो शुरू में अवेलेबल होते हैं, और एकदम देखिए इंक्रीज आता है शुरू में। ठीक है, जबकि टाइप 1 में पूरा यानी ज्यादा इंक्रीज आएगा, लेकिन इसमें एकदम थोड़ा सा इंक्रीज आएगा, यानी मोनोलेयर कवर हो गई है सारी। तो उसके बाद आपके पास क्या आ गया जी, ना तो वो पोरस है, तो सरफेस पे ही आपके पास चीजें रहेंगी, तो मल्टी लेयर बनेगी। फिर आहिस्ता आहिस्ता आपके पास प्रेशर आप बढ़ाते जाएंगे, लेकिन आहिस्ता आहिस्ता एड्सॉर्प्शन बढ़ेगी। सो ये मल्टी लेयर बन रही है इनके ऊपर, जो आपके पास एड्सॉर्प्शन बढ़ रही है। सो ये टाइप 2 आइसोथर्म्स हो गया। उसके बाद चलते हैं टाइप 3 और टाइप 4 आइसोथर्म्स में टाइप 3 इज लाइक ब्रोमीन ऑन सिलिका जेल। उसकी जो एग्जांपल है आपके पास कि अगर आप ब्रोमीन को अपने सिलिका जेल पे एट 352 केल्विन पे एब्जॉर्ब करवाना है तो उस वो ये ट्रेंड शो करता है। उसके अलावा water vapors on charcoal at 373 Kelvin, they also show these type 3 trends. So there is no rapid intake uptake of the gas. अब यहाँ पे देखें ये सिमिलर टू है अनफेवरेबल। अगर आप जैसे पिछला जो मेन ग्राफ देखें उसमें फेवरेबल, अनफेवरेबल और लीनियर ट्रेंड थे, तो ये ज्यादातर जो है वो अनफेवरेबल ट्रेंड को जो है ना वो रिप्रेजेंट कर रहा है। तो इसमें आपके पास एकदम कोई रैपिड ऐसे नहीं होता, यानी आपके पास स्लोली स्लोली जो है ना वो एड्सॉर्प्शन इंक्रीज कर रही है। सो द फोर्स ऑफ एड्सॉर्प्शन टू फर्स्ट मोनोलेयर आर रिलेटिवली स्मॉल। यहाँ पे क्या है कि आपके पास जो एड्सॉर्प्शन की और एड्सॉर्बेंट की और एड्सॉर्बेट की जो आपस में फोर्स ऑफ अट्रैक्शन है वो बहुत स्मॉल है। सो दीज आइसोथर्म्स आर वेरी रेयर। नाउ वी मूव टू द टाइप 4 आइसोथर्म्स। टाइप 4 आइसोथर्म्स क्या हो गई जी, आपके पास बेंजीन को एड्सॉर्ब करवाना है आपने आयरन ऑक्साइड जेल के ऊपर और ये 320 केल्विन के ऊपर। यहाँ पे भी आप देखिए कि आपके पास रैपिड एक, अब ये भी आपको किसके रिप्रेजेंट कर रहा होगा, सिमिलर ट्रेंड है आपके पास टाइप 2 से, कि आपके पास रैपिड इंक्रीज आता है शुरू में, यानी मोनोलेयर बन गई, फिर आपके पास जो है ना वो तकरीबन स्टेबल रहता है एड्सॉर्प्शन, फिर आहिस्ता आहिस्ता वो बढ़ना शुरू हो जाता है, यानी ये मल्टी लेयर होती है। ठीक है जी, तो ये भी आपके पास जो है ना वो शुरू में रैपिड इंक्रीज आता है, फिर आपके पास जो है ना वो आहिस्ता आहिस्ता इट्स स्टार्ट इंक्रीजिंग। सो लेवल ऑफ नियर द सैचुरेशन वेपर प्रेशर, अब यहाँ पे जाके ये ऊपर जाके बिल्कुल लेवल हो जाता है यहाँ पे। ठीक है, आल्दो के ट्रेंड इस तरह जा रहा है तो इसको ऊपर जाना चाहिए, लेकिन ये सीधा हो जाता है ट्रेंड। डॉटेड लाइन शो कर रही है कि इसको ये ट्रेंड फॉलो करना चाहिए था, लेकिन इट लेवल्स ऑफ एट द टॉप, और इसे कहते हैं कैपिलरी कंडेंसेशन इन द पोरस सॉलिड्स। ठीक है जी, अब ये भी आपके पास ये ज्यादातर जो लिक्विड टाइप होते हैं, लिक्विड्स जो फीड है वो जब आप एब्जॉर्ब करवाते हैं, जब गैस बेसिकली हो तो टाइप 1 बनेगा, जब लिक्विड एब्जॉर्ब करवाएंगे तो लिक्विड जो है, अब इस पे भी आपके पास जो है वो पोरस केस है, और जो लाइक मल्टी लेयर है आपके पास, और इसमें आपके पास जाके लिक्विड्स जब ऊपर आके पोर्स को ब्लॉक कर देते हैं तो एक कैपिलरी एक्शन वहां पे आता बनता है, जिसकी वजह से वो जाके एड्सॉर्प्शन बिल्कुल साइड्स ब्लॉक हो जाती हैं। तो जब प्रेशर मजीद बढ़ाए तो आपके पास जो है ना वो एड्सॉर्प्शन जो है वो कांस्टेंट रहती है, वो ऊपर नहीं जाती। ठीक है जी, इसको कहते हैं कैपिलरी कंडेंसेशन पोर सॉलिड्स। So effective pore diameters usually be between 2 nanometers to 20 nanometers. The upper limit of the absorption is mainly governed by the total pore volume. So these are this is for the type 4. So type 5 also is similar, but it's more of like similar to the type 3, like in the start. सो टाइप 5 में आपके पास जो है ना वो शुरू में भी आपके पास रैपिडली इंक्रीज नहीं होता, और जो है वो जो है आहिस्ता आहिस्ता इंक्रीज हो रहा है। ये भी आपके पास मल्टी लेयर है, और ये भी केसेस फॉर द ये केस है कि आपके पास एड्सॉर्बेंट और एड्सॉर्बेंट की जो आपस में फोर्सेस ऑफ अट्रैक्शन है वो बहुत स्मॉल है एज कम्पेयर टू टाइप 1, और ये भी ऊपर जाके आपके पास लेवल ऑफ हो जाता है बजाय के ट्रेंड ऊपर जाने के। सो ये भी आपके पास जो है वो मोस्टली लिक्विड्स और सॉलिड्स में इनकाउंटर होता है, और इट कुड बी मल्टी लेयर, क्योंकि जहाँ पे आपके पास आहिस्ता आहिस्ता इंक्रीज आ रहा है दैट मीन्स के मोनोलेयर बन गई है, और उसके बाद भी एब्जॉर्प्शन आहिस्ता आहिस्ता इंक्रीज हो रही है क्योंकि मल्टी लेयर भी बनती जा रही है। और जी, सो these are the 5 types. Now again you can see here, now I think you easily understand that what's happening and why there are different types of BET isotherms. So let us conclude the today's lecture. We have discussed about the different adsorption isotherms. One is the linear trend, one is the Langmuir isotherm, जो type 1 है आपके पास, उसको हम linear भी कहते हैं अपना Langmuir isotherms भी कहते हैं। Then we have BET isotherms, ठीक है जी, टाइप 4 हेयर शो कर रहा है। देन वी हैव फ्रंटलिच, जो मेन ग्राफ था आपके पास वो बेसिकली उसे फ्रंटलिच आइसोथर्म्स भी कहते हैं, और ये आपके पास दिस इज अनफेवरेबल, दिस इज लीनियर ट्रेंड, दिस इज favorable trend. So I hope I make you understand. If you have any questions or any difficulties in order to understand this today's lecture, you can email me or WhatsApp me or meet me in the personal at my office. Thank you very much. Thank you very much, class, and see you again for the next lecture.